Hello everyone, welcome back to Number School. In today's lesson, we are diving into the world of trigonometry. I know terms like sine, cosine, tangent, secant, cosecant, and cotangent. All these sound a bit intimidating at first, but don't worry. By the end of this video, you'll see how simple and fascinating these concepts really are. Before we jump into definitions, let's start with a fun activity to explore these ratios ourselves. Okay, let's take 2 to 3 graph sheets, your ruler, and let's get started. Okay, step 1, let's draw the x and y axis on your graph paper and label them appropriately. From the origin, that is where the x and y axis meet, draw a straight line at a specific angle. Let's say 30 degrees for our first example. Along this line, pick various values for x and find the corresponding y values on the line. For each point, calculate z, where z is square root of x square plus y square. This z value represents the hypotenuse of the right angle triangle formed. Let me continue this act for x is equal to 4 and 5. And at the same time, compute the value of z and write it here. After this, let's tabulate your results in a table like this. Notice here the value of x divided by z is equal to 0.87 for all the values of x. And similarly, the y divided by z is 0.5 for all the values of x. And the ratio of x to y is 1.73 for all the values of x. Now, let's repeat this activity for angles of 45 degrees and 60 degrees. You'll Even in this case of 45-degree line, you can notice that the value of x divided by z is 0.71 for all the values of x, and the value of y divided by z is 0.7 for all the values of x, and again the ratio of x by y is also 1 for all the values of x. Let me repeat this exercise for the 60-degree line. Here also you can notice that the value of x divided by z, value of y divided by z, and value of x divided by y remains same for all the values of x. Remember when we learned about similar triangles? If two triangles have the same angles, they are similar and their sides are proportional. This principle is the foundation of trigonometry. So if we can calculate these ratios for one right angle triangle with a given acute angle, we can use them for any right angle triangle with the same angle. Now let's formalize these ratios. In any right angle triangle, we will have the side opposite to the angle we are focusing on. Let's call this as opposite side. Then there is the side next to the angle, but not the hypotenuse. So let's call this as adjacent side. Then we have the side opposite to the right angle, the longest side. Let's call this as hypotenuse. Let me repeat. In any right angle triangle, we will have the opposite side. This is the side opposite to the angle that we're focusing on. Then we have adjacent side, the side next to the angle but not the hypotenuse. Then we have the hypotenuse, the side opposite to the right angle. This is the longest side in the right angle triangle. Now let's get into the formal definition of the key trigonometric ratios. Sine of angle theta equals opposite side divided by hypotenuse. Right? The sine of angle theta is the ratio of the opposite side to the hypotenuse of the right triangle. Cosine of theta is the ratio of adjacent side to the hypotenuse. So cosine of theta is the ratio of adjacent side to the hypotenuse. So the tangent of angle theta is the ratio of opposite side and the adjacent side. Tangent of angle theta, which is written as tan theta, is the ratio of opposite side to adjacent side. In addition to sine, cosine and tangent, we have their reciprocals. So cosecant theta is the reciprocal of sine theta. So it is hypotenuse divided by opposite side. We can also say cosecant theta is the ratio of hypotenuse to its opposite side. We have secant theta. We can write it as sec of angle theta, which is the reciprocal of cosine theta or simply cos theta. So this can be expressed as a ratio of hypotenuse to the adjacent side. Then the last one, cotangent. So cotangent is the reciprocal of tangent of angle theta. So cotangent or cot theta can be represented as the ratio of adjacent side to the opposite side. Clear? Now that we have learnt about definition of various trigonometric ratios, let's try to calculate trigonometric ratios for some key angles. Let's get started with 45-degree angle. Here I have taken a right angle triangle with angle C as 45 degree, and since angle B is 90 degree, angle A must also be 45 degree. So we have a isosceles right angle triangle here. So the side BC and side AB is equal to A. Using Pythagoras theorem, in this triangle can we write AC square is equal to AB square plus BC square. So let's compute AC square since we know AB and BC are equal to A. So AC square becomes A square plus A square. So AC becomes square root of 2A square, which is A times square root of 2. Okay, let's write down side AC equals to A root 2. Now we know that all length of all the sides of the triangle, it will be easy for us to compute the trigonometric ratio. Let's start with computing trigonometric ratios sine of angle 45 degree. We have learned that sine of any angle is equal to opposite side divided by hypotenuse. Here side opposite to angle C, which is 45 degree, is AB. So sine 45 degree is equal to AB by AC. So which is A divided by A times square root of 2, which is 1 by root 2, which you can also rewrite as square root of 2 by 2. But my preference for writing sine 45 degree is 1 by root 2. With the same logic, we can also calculate cos of 45 degree, which is also 1 by root 2. Let's compute tan of 45 degree. So here opposite tan of 45 degree is opposite side divided by adjacent, which is equal to AB by BC. Now we know that AB and BC are equal to A. So A divided by A is equal to 1. So tan of 45 degree is 1. Now that we have derived the value of sine 45, cos 45 and tan 45, let's move on to other trigonometric ratios, which will be easy because these are just reciprocals. So let's start with the cosecant of angle 45 degrees, which is 1 over sine 45. Then we have an answer as square root of 2. Similarly, secant of 45 degree is reciprocal of cos of 45 degree, which is again equal to square root of 2. So cotangent of angle 45 degree is equal to 1 divided by tan 45 degree, which is 1 again. Now let's derive trigonometric ratios for angle 60 degree and 30 degree. This is a very interesting derivation, I must say. So let's consider an equilateral triangle. So since it's an equilateral triangle, all the sides are equal and all the angles are equal. So let's consider each side to be of length 2a. So Angle A, angle B and angle C will be 60 degree as it is an equilateral triangle. Now let's make a construction. Let's draw a line AD which is perpendicular to the line BC, right? In triangle ABD, angle ABD plus angle BAD plus angle BDA equals 180 degree, right? So because these are some of interior angles of a triangle which has to be 180 degree. We know angle ABD is equal to 60 degree and angle BDA is equal to 90 degree because angle the line AD is perpendicular to BC. By using this information, we can calculate angle BAD, which is equal to 180 degree minus 60 degree plus 90 degree. So using this and just doing simplification, we get angle BAD is equal to 30 degree. So let's write it, angle BAD equals 30 degree in this diagram. Similarly, in the triangle CAD, we can calculate angle CAD to be 30 degree. So now we have angle BAD is equal to 30 degree, angle CAD is also equal to 30 degree. Let's indicate that here. Notice we have split the original equilateral triangle ABC into two isosceles right angle triangles ABD and CAD. And also notice these two triangles are congruent. What I mean by congruent is if you overlap them one over the other, they match exactly, right? So the green triangle here exactly overlaps with the orange one here. These two are identical copies, I can say. Now that we know angle ABD and angle CAD are congruent, so the side BD will equal to side CD, which is equal to A. Note that originally the whole length of BC was 2A, therefore the side length of BD and CD will become A. Using Pythagoras theorem in this triangle, we can compute AD square, which was the altitude that we drew, right? So AD square is equal to AB square minus BD square. We know the value of AB, which is 2A, and we know the value of BD, which is A. With simplification, we'll get AD square equals 2A whole square minus A square, which is 4A square minus A square, which we can write it as 3A square. So AD will become 8 times square root of 3, which we can write as A root 3. Okay, now let's update the diagram. So AD length becomes A times root 3. I've added it here. Notice now I can split them into two different triangles where I can take angle B as 60 degree and then I can compute the trigonometric ratios. Let's start with the green triangle first and compute trigonometric ratios for the 60 degree. And we will bring back this orange triangle later when we compute for 30 degree. So let's calculate trigonometric ratios for 60 degree. So sine of 60 degree is again, I'm using the definition opposite side by hypotenuse. AD divided by AB. We computed AD to be A times square root of 3 and we knew AB as 2A. So with simplification, we'll get sine of 60 degree equals square root of 3 divided by 2. Clear? Let's start for cos 60 degree. We know by definition cos of any angle is equal to adjacent side divided by hypotenuse. The adjacent side here is BD and the hypotenuse is AB, right? So A divided by 2A will get simplified into 1 divided by 2. So cos of 60 degree is equal to 1 divided by 2. Tan of 60 degree equals opposite side divided by adjacent, which is AD divided by BD. We know AD is equal to A times root 3 and BD is equal to A. So we have tan 60 degree as square root of 3. After calculating sine, cos and tan, it will be easy for us to compute the values of their reciprocals, right? So let's see what is the cosecant of 60 degree. Cosecant 60 degree is equal to 1 by sine 60 degree, which we can write it as 2 divided by square root of 3. Secant 60 degree is 1 by cos of 60 degree, which is 2. Cot of 60 degree is equal to 1 by tan 30 degree, which is equal to 1 by square root of 3. Now let's compute the trigonometric ratios for 30 degree. Let's bring back the orange color triangle that we had earlier constructed, right? In this diagram, so the sine of angle 30 degree will be opposite by hypotenuse side. So side opposite to 30 degree is CD. We will divide it by hypotenuse AC. So we have CD equals A and then hypotenuse equals 2A. So then sine 30 degree is equal to 1 by 2. So cos of 30 degree angle will be equal to the ratio of adjacent side to the hypotenuse. We have adjacent side as ED and hypotenuse side as AC. So let's substitute the value for AD and AC. We know AD equals A times square root of 3 and AC equals 2A. After simplification, we have cos of 30 degree as square root of 3 by 2. Let's compute tan of 30 degree. We know tan of any angle is opposite side by adjacent side. Here the side opposite to 30 degree is CD and side adjacent to 30 degree angle is AD. We know CD equals A and we know AD equals A times square root of 3. After simplification, we have tan of 30 degree as 1 by square root of 3. Now we know sine, cos and tan. Let's calculate cosecant, secant and cot of 30 degree angle. Cosecant 30 degree is equal to 1 divided by sine of 30 degree, which is 2. Secant 30 degree is 1 by cos 30, which is 2 by square root of 3. And the cot of angle 30 degree will be square root of 3. Let's derive the value of trigonometric ratios for angle 0. I've taken a triangle ABC. So notice here I'm gradually decreasing the angle A. So what is happening to the opposite side BC? The length of BC is becoming 0. So sine of 0 is equal to opposite by hypotenuse. So that is BC by AC. We know that BC equal to 0 here. So sine of 0 is 0. Cos of 0 is adjacent by hypotenuse, which is AB by AC. As you noticed, so as angle A became 0, AB became AC, right? So that's why cos 0 is equal to 1. So tan 0 is equal to BC divided by AB. So we know BC became 0 here. So tan 0 is 0. Now it is easy to find their reciprocals. Secant 0 will be 1 over cos 0, which is 1. Cosecant and cot will become undefined because 1 over 0, we cannot have a distinct value. Let's derive trigonometric ratios for angle 90. I've taken triangle ABC here, right? So see how I increase the value of angle A from 45 to 90. As angle A becomes 90, one interesting thing happens. Hypotenuse AC is equal to opposite side BC now, and then the adjacent side AB is 0. Now let's compute the trigonometric ratios. Sin 90 is equal to AC by AC, which is 1. Cos 90 is equal to AB by AC, which is 0 by AC, which is again 0. Tan 90 will become BC divided by AB. So we know AB is equal to 0. So we can say tan 90 is undefined. Let's derive other trigonometric ratios which are reciprocals of this. Cosecant 90 is again 1, secant 90 is undefined, and cot 90 will be 0. Okay, so I have tabulated the results of all the derivations that we did for angle 0, 30, 45, 60 and 90 here. This table is very important. So I also want you to see and observe some patterns. See, sine theta increases gradually from 0 degree to 90 degree. So sine goes from all the 0 to all the way 1. So sine increases from 0 to 90. If you notice, cos is the opposite. Cos goes from 1 to 0. As angle becomes 0 to 90, cos starts decreasing. Also notice one more thing. Sine 30, which is 1 by 2, is also equal to cos 60, which is 1 by 2. And sine 60, which is square root of 3 divided by 2, equals to cos 30, which is again square root of 3 by 2. This table will be very handy for all your examinations. So my tip is to memorize sine of 0, 30, 45, 60 and 90, and other ratios you can easily impute knowing this. The most important trigonometric identities. We can also call this as Pythagorean trigonometric identities. I've taken a right angle triangle ABC, which is right angled at angle B, and let's call angle A as angle theta. Right? I have indicated the opposite, adjacent, and hypotenuse in this diagram. By Pythagoras theorem, AB square plus BC square is equal to AC square. Let's divide both sides of this equation by AC square. What do we get? AB square divided by AC square plus BC square divided by AC square is equal to AC square divided by AC square. Right? AB is nothing but adjacent side, BC is nothing but opposite sides, and AC is nothing but hypotenuse. By definition, we know adjacent divided by hypotenuse is cos of angle theta. Opposite divided by hypotenuse is sine of angle theta. Hypotenuse square divided by hypotenuse square will become 1. So we can readjust this equation into sine square theta plus cos square theta is equal to 1. This is our identity number 1. Now let's divide this equation by AB square. What do we get? AB square by AB square plus BC square divided by AB square, which is equal to AC square by AB square. Let's substitute for adjacent, opposite and hypotenuse. And we can simplify this into 1 plus tan square theta is equal to secant square theta. This is our identity number 2. Let's divide this equation by BC square. What do we get? AB square by BC square plus BC square by BC square is equal to AC square divided by BC square. AB will become adjacent and BC will become opposite and AC will become hypotenuse. After simplification, we will get cot square theta plus 1 is equal to cosecant square theta. Thank you so much for watching this video. I hope you found this video useful. If you have any feedback on the pace or the style of explanation, please drop a comment here. I'll try to improve my next video. In the next video, I'll also bring the exercise problems and then detailed solutions for the 10th class trigonometry, introduction to trigonometry topic. Thank you so much once again. If you found this video useful, like the video, share your comments and share with your friends, and also don't forget to follow our channel.